Okay, we have our two example nodes on the screen. Now let's see how we can drag them around. The browser already features a drag API, where we can set drag event handlers on any elements to be called at the start, during, and at the end of a drag. But that API has some bugs and some counterintuitive behaviors, so I usually stay away from it, except when I need to handle dragging something like a file from outside the web page. But to move a node right here on the same page, we can just use the mouse up, mouse down, and mouse move events, which are just so much easier to work with. We have two choices here for how we approach it. We could set different event handlers on each thing that can be interacted with. One set of handlers on the nodes, another set on the edges, and another one on the grid itself, and so on. You might call this a more modular design. But I prefer to have the entire mouse logic in a single place. This may not be as modular or as customizable from the outside, but it does give us a lot more control over exactly how the mouse events are handled. And that's why I set only one set of mouse event handlers on the editor itself. Okay, within the handlers, the first thing we want to know is whether the mouse was over a node or not, and if yes, which one. We can't rely on e.target alone here, because that only gives us the elements directly under the mouse, which may not be the node itself, but one of its children, even though at the moment nodes don't have any children. So we use the method called closest, which starts a search at the element directly under the mouse, going up the hierarchy to find the element that matches this selector. We need an extra state that represents the ID of the node being dragged, which we read from the node's DOM element in the mouse down event handler. And of course, let's make sure that we do put the ID of the node on the node element in the final HTML. As the mouse moves, we update the workflow state to set the X and Y coordinates of that node to follow the mouse. By the way, if you're not used to seeing this way of updating a state, you might want to look up the concept of immutability in React. But in short, we don't mutate a state like this, because this doesn't change the identity of the state. It is still going to be the same workflow object, only with different content. And that would confuse React whether it should re-render or not, because React only performs a very fast identity comparison between the old state and the new state. And if the identities are the same, it might not trigger a re-render of the components. And another cool thing about not mutating the state is that we can store the state before and after every single change, which makes implementing undo and redo very simple. But if you were to mutate the states directly, the implementation of undo and redo would be more complicated. For larger projects, I usually use a library like Next.js to help simplify this, which basically does the same thing behind the scene. Okay, finally, we unset the drag on mouse up, and now we can actually drag the nodes. Great, but we have a couple of problems here. First, the browser keeps trying to select any text it finds as we drag the mouse. That's obviously the default behavior of the browser, so let's prevent the default behavior. Another problem is that the node jumps at the start of the drag, because we set the position of the top left corner of the node to follow the mouse. At the start of the drag, we must store not only the ID of the node, but also where on the node the mouse was, the offset relative to the node itself. We could of course use another user state for that, but notice that these two pieces of information, the ID of the node and the relative point, are set and unset together. They live together, they die together. So it makes a lot more sense to group them together as a single object. On mouse down, we get the bounding box of the node under the mouse and calculate where the mouse is inside that box. And then if we apply this offset during dragging, the nodes don't jump around anymore. And as an indication that the nodes are movable, let's change the cursor when the mouse is over a node.